November 2022, paper 51. A student attempts to determine the percentage by mass of magnesium chloride in the solid mixture containing magnesium chloride, MgCl2, and anhydrous magnesium nitrate 2 using the following method. Accurately weigh about 1.5 gram of the solid mixture and record the mass. Dissolve the solid mixture in distilled water. Add an excess of silver nitrate solution. Filter the solid mixture and wash the precipitate collected with distilled water. Dry the PPT in an oven. Weigh the PPT and record the mass. In this process, only the chloride ions from the magnesium chloride form a PPT with the silver nitrate solution. In this process, only the chloride ions from the magnesium chloride form a precipitate with the. So we are getting that AgCl, a very famous reaction. One student in the class obtains the following results. Mass of solid mixture is 1.52. Mass of silver chloride solid after drying is 3.63. After drying is 3.63. So should we make a subtraction?
Yes.
So when I subtract it in the sample, but he says amount. Amount means number of moles. Mass of silver chloride solid after drying. So how should we do that? Do we have silver mass? I'm sorry. This is the data booklet time now. So how we get the molar mass of silver chloride? So can you get the masses for silver and chlorine?
Yes.
How much for silver?
For silver, it's 107.9.
107.9. And for chlorine?
35.5.
Right. So add them.
It will be 143.4. The final answer is 0.025 moles.
Is it the division of 3.63 by 143.4?
Yes.
How much it is? 0 point?
0.025.
And any number after 5?
Yeah, 3.
What is the ratio of magnesium chloride and silver chloride? The ratio is 1:2.
Yeah.
So what should I do for? Should I have these moles?
Yeah.
So I have to show examiner that look, AgCl is 2. AgCl ratio MgCl2 is 2:1. So number of moles for MgCl2 is equal to 0.0253 upon 2.
It will be 0.0127.
0.0127 mole.
Yes.
Okay, that's good. Then he says, use your answer to part 1 to calculate the percentage by mass of magnesium chloride. Percentage by mass of magnesium chloride in the sample if you were unable to answer one. So he says calculate the percentage by mass of magnesium chloride in the sample. So how we find the percentage by mass? For that we need two things. We need the total mass. What mass have they given us? Any mass? About 1.5 gram of solid mixture. 1.5, but later what is gave?
The 1.5 is the mass of the solid mixture.
Yes, and but actually the mass of solid mixture is 1.52. So I have the total mass. But I don't know the percentage. We know the mass of magnesium chloride. I have the moles. So should I convert the moles into mass?
Yeah.
Mass
The
is
zero,
equal to number of mole into MR. So when I try to find magnesium chloride, so it is 0.0127. 0.0127 into MR. What is the MR of magnesium chloride? Magnesium is 24 plus 35.5 into 2.
it's 95.
Acha. In 95 into 0.0127.
1.2.
Make a double check. What is the mass of magnesium in periodic table? Is it 24 or 24 point something?
It's 24.3.
Oh. So what is the final answer now?
1.21.
1.21. So this is my mass of magnesium chloride. So let's make percentage 1.21 upon 1.52 into 100.
It will be 79.6.
Suggest what the student could do in step 2 to ensure the solid dissolve as quickly as possible. So what about the quick solvation? So he should increase the temperature or you use a stirrer. I think increasing the temperature is not a good idea, but what about stirrer?
Yeah.
Normally we use stirrer na, at in chemistry lab also. To use a stirrer. Explain why the precipitate was washed with distilled water before it was dried. This is a very common procedure.
To remove the impurities.
Um, so washing actually is done for this to remove impurities. But what impurities we have to mention that.
Maybe the silver nitrate. No, the magnesium.
Maybe silver.
The
Maybe some
magnesium.
unreacted nitrate, or maybe some magnesium nitrate absorb on the precipitate.
Mm.
So we can mention examiner that we should remove the impurities and suggest why the precipitate is dried in an oven and not by direct heating with a Bunsen burner. Oven means that you are using a safety or precaution that might there is something which can decompose.
Mm.
Because apparently there is nothing flammable. Yes. Apparently there is nothing flammable. So I think it is not a safety precaution in that sense. It might be a precaution like saving something. So think on that.
So the AgCl will undergo thermal decomposition. Or the
Which one?
magnesium nitrate.
This is a possibility that any of the compounds involved in the reaction so maybe our precipitate is silver chloride. to prevent thermal decomposition. In step 1, a small beaker was weighed using a balance accurate to 2 decimal place and its mass recorded. The sample was placed in the beaker and the mass of the beaker increased by 1.52 gram. Now, what he says now, he says 2 decimal place. So he says there is an error. There is an error in reading the mass. The 2 decimal means it's a pure mass question. Two decimal means 0.01.
So when they don't give the reading, we should assume it's 0.01.
Actually, when you say something is accurate to 2 dp, it means it can read like 0.01. Now, this is a concept from our GCSE maths that how you find the possible error in anything. The chapter, the topic was called upper bound and lower bound. This was a topic, upper bound and lower bound, and this idea can be used in that respect.
Okay.
So when it is upper bound, lower bound, so I can write uh, 0.01 is divided by 2. It's always divided by 2.005. This is the value for upper bound and lower bound. Now, so how should I now? Acha, this is another point. When you take any reading twice, because first you read the original mass, the mass of the beaker, and then you put the beaker with the weight and you subtract them. So when you take 2 readings in any measurement, the error will be twice. When you take 2 readings from any instrument, the error will increase by a multiple of 2. So the error will be 2 into 0.005. 0.01. So you should remember this physics concept, this concept of physics, how you take, concept of maths, that how you tackle these values, how you tackle an uncertainty in any data. 0.01. Now you have to see the percentage error. Error is 0.01. So you divide it by 1.52 into 100.
It will be 0.658.
Okay. 0.66.
Mm.
Other than by changing the balance state, how this percentage error can be reduced. Now, this is again a physics style question. How the error can be reduced. Physics says a very interesting rule. The error percentage, not the error itself, percentage can be decreased by taking a bigger sample. Actually, when you are talking about the error in the instrument, here like 0.005, it doesn't matter you measure 500, you measure 200, you measure 300. So here you are measuring 1.52. If you measure 100 gram, the error will remain the same, but in percentage, error will reduce. It is the same concept in physics, like your watch has a 2 minute ahead. Okay, your watch is 2 minute in error. So when you measure 1 hour, when you measure 1 hour 60 minutes, you can find the percentage error. But if you measure 500 minutes, then error percentage wise will reduce. So you will tell the examiner that the student should take a bigger sample, bigger mass, greater mass.
Okay.
Use a sample with greater mass. This is again a pure concept from physics. State what could be done in step 5 to ensure that the precipitate was completely dried. We can do one thing, we can wash it 2-3 times, and we have to keep on weighing. When the mass becomes constant and washing is not changing the mass anymore, it means that washing is complete.
Yes.
Washing is complete and dry. Second option, we dry it every time, and we keep on washing, keep on drying until the mass remains constant, mass becomes constant. So we can tell the examiner that, look, you have to dry periodically. Wash, dry, and wait until mass becomes constant. D, 1D. So if the student does not dry, the sample will be wet. When something is wet, it will be heavier. Normally, anything which is wet, even a even a sponge, when it is wet, it becomes heavy. So it means it will be overweight.
Mm.
U2 sample will be overweight. So what about the percentage now? Percentage will be definitely different. So will we expect more percentage now, because system will consider every mass as MgCl2.
Yes.
Because then we see percentage by mass of MgCl2 will increase. Charles' law states that for a fixed mass of gas at constant pressure, its volume is proportional to its absolute temperature. Most gases are non-ideal and do not obey this law. But at lower pressure and higher temperature, some gases are close to ideal behavior. One gas that behaves like this is oxygen. Oxygen can be prepared by decomposing hydrogen peroxide with the catalyst manganese oxide. The equation for the decomposition of hydrogen peroxide is shown. 2H2O2 gives you 2H2O plus O2. Safety hazard, hydrogen peroxide is corrosive to skin and can cause serious eye damage. We have a gas syringe, we have oxygen in it, we have thermometer, beaker, and water. And we are heating it. Once the apparatus is assembled, the volume of oxygen in the gas syringe is 2 centimeter cube. There are 80 cm cube of oxygen remaining in the flask. The total volume of oxygen is 82. Charles' law is investigated by the following method. Once assembled, allow the apparatus to reach room temperature, record this temperature and the total volume of oxygen reading on the syringe. Gently heat the apparatus until the temperature reaches 30 and record the total volume of oxygen. Repeat at intervals of 5 degrees until the temperature reaches 70. So let's read it once more. The story he is using, and then we can go for the first part.
Mm.
The student carried out the experiment and obtained the following results. Temperature column, absolute temperature, and total volume of oxygen gas. 82, 84. Okay, this is the data. other than the wearing of safety goggles, give us safety precaution. He already told us that this is a danger for skin. Already safety goggles are there for eye, but what about skin?
So I should wear the gloves.
What about the lab coat? The skin is also to be
Yeah.
protected. Wear safety gown. Wear safety gloves. Complete the following diagram to show how the student can obtain oxygen by gas collection over water for use in the experiment shown. So should we put a bung, something like that? We have a pipe here, and the pipe should be bending, and it should be uh-oh. Should I insert a cylinder in the apparatus? Inverted cylinder.
Yeah.
Like this. Now look this. Now this is our apparatus ready for the job.
Mm.
Suggests how the student could ensure they collect pure oxygen gas in the conical flask. So whenever you are using a syringe apparatus or any gas collection apparatus and you pull air in it, the first is even if you have seen a drip like that. So when you first pull it in, it will be always air. So some of the initial gas is always air. So how we can assure it?
We can wait longer.
We should wait a bit. So just make a sentence here. So we can tell examiner that they should wait for some time before taking the reading. So do not collect the initial supply of the gas.
Okay.
Plot a graph on the grid to show the relation between volume of oxygen and absolute temperature. Use a cross to plot each data. Draw a line of best fit. Total volume of oxygen and to absolute temperature. Total volume. Total volume and absolute temperature. So 24 comma. First point is 24 comma 82.
They're taking the absolute temperature, so it's 297 and 82.
Can you repeat? 24 on sorry, total volume of oxygen gas.
It's 297 and 82.
Absolute temperature. 24 and 297, right? But 297 and 82, right? 297 and 82, right? 297 here. Then it is 303 and 84. And 308 and 88. Three 13 and 88. Oh, it's repeating number. 13 and 88. Three 318 and 89. 318 and 89. 318. Three 23 and 91. 323 and 91. 323 323. अच्छा 328. 328 and 93. Triple 395. Three three eight 97. 338. Now you see that it is 343. 343.98. 343 and 98. What type of graph he's expecting? Is it? It's not looking to be a single graph, like a step graph. Is it coming? It's not coming to be a straight line. So what about
But
the point?
he's
What?
asking for the,
Yes, please go ahead. Is it going to be a straight line?
yeah, he's asking for the line of best fit.
So if so, let's draw a straight line, which is somehow line of best fit. I'm getting this line.
Yeah, me too.
So now you have to find the gradient.
Yes. My gradient is 0.27.
0.27.
Mm.
Three 41 and 97, 97 point, 97, 97.2, 97.4. So I'm getting these points. So well, we can find gradient accordingly. On the graph, circle the point which you believe to be the most anomalous. In my case, this is to be the most anomalous.
Yeah, for me too. At temperature 308.
Hmm. Suggest a possible explanation for this anomaly.
Maybe the temperature was less than measured.
Maybe. A long question, my God. Another table. Identify the independent variable which we are changing.
The temperature.
Hmm. Suggest how the experiment could be made to be more reliable.
Repeat.
That's a political answer. Obviously, every experiment can be proved by that. So you can say repeat, but there might be some reason, some precaution related to the experiment. The ideal gas equation is shown. P is the pressure of the gas in Pascal, V is the volume. Using this equation, describe how the gradient of the graph you have plotted would be affected by using a smaller volume of oxygen at the start of the experiment. Explain your answer. What was our graph? Our graph was volume against Kelvin temperature. Volume against temperature. PV is equal to nRT. So V upon T is equal to N R upon P. By using a smaller volume of oxygen gas at the start of the experiment. So I have done the mathematical work. We know the gradient actually, but how we manage this now? When
Are they
he says,
asking to calculate?
he says smaller volume. So when I decrease the volume, logically gradient should decrease. Then what is the involvement of this NR upon P? Gradient will decrease. The graph will be shallower.
Yeah, but did they give the equation for us to calculate something?
No, actually, I think this is only a descriptive thing. He's not asking to calculate, but he says using this equation. Interestingly, it's going without equation. V upon T is equal to NR upon P. N and R are constant.
Mm.
It's very strange. That's fine by now, but for this, how PV is equal to nRT is involved. Oh, this is a confusion. Gradient and V upon T are linked. But that was already linked. What's the purpose of giving this equation? No. No, no link is establishing. So